All right, so this was the first solution for you guys, okay? We went over it. I just kind of put it on here last time, just because of the fact that I wanted you guys to have it. I know we did it in class, and everything, but you guys should have gotten that answer, okay? And negative 128 over 81 pi inches per minute. Now, if you are going to write your answer in decimal form, then make sure that you guys always have 3 numbers after the decimal, okay? So you want to make sure that, let's just pretend that this was your answer, 0.0358. You either leave your answer as 0.035 or 0.036, okay? Round it or not, it's up to you, but make sure you leave 3 numbers after. Okay, I'm not saying that that's the answer of 128 over 81 pi, but I'm just saying if you wrote it as a decimal, then, you know, do that. Okay, always either round or don't round, that's up to you. But the important thing is you leave 3 numbers after the decimal. Unless the number terminates. So like if your answer was half and you write 0.5, that's fine. You don't have to put 0.500. Okay, second question. Now, I think I finished this one up, so let me just kind of walk you through, and then we'll kind of do the other ones together. So, second question said, air is being pumped into a spherical balloon at a rate of 7 cubic centimeters per second. What is the rate of change of the radius at the instant the volume equals 36 pi? They give us the volume of the sphere as V equals to 4/3 pi r cubed. So, I reread the question. Again, the question says that air is being pumped into a spherical balloon, so I have a sphere, at a rate of 7 cubic centimeters per second. So cubic centimeters is volume, and then you have per second, so it's volume over time. So it's the rate of change of volume over time. That's why I put dV dt is 7 cubic centimeters per second. If I keep reading, it says, what is the rate of change of the radius? So rate of change means derivative. Okay, so derivative of the radius when volume equals to 36 pi. So I put that right there as well, 36 pi on the bottom. Okay, but I don't know the answer to that, so I'm about to start working on that. So I was going to do all this stuff and then just send it to you, but I figured maybe it'd be best for you guys to hear it. So we start off with the stuff in red, okay? So I got my volume equation. Volume equals to 4/3 pi r cubed. And I took a derivative of it. Okay, so dV dt is equal to 4 pi r squared dr dt. Because the power of 3 will cancel out with the denominator of 3. And then you're going to have an r squared. Okay, so right here, you'll notice that the denominator of 3 cancels out. Okay, now once you do that, your objective is to find dr dt. So I start solving for dr dt by dividing both sides by 4 pi r squared. So that's this next step coming up right here, right? So I divide it by 4 pi r squared. Now at that point, I say, okay, if I need to solve for this, I need to plug in some numbers, but they gave me volume equals to 36 pi. I think I just put the wrong thing. It's 36 pi, right? So let me write that out properly. So the volume is equal to 36 pi. Now you notice under there I put r equals 3. The reason why I put r equals 3 is because I came over here and did some work, okay? I had to solve for the radius. Okay, r equal 3. So how did I solve? Well, I used the volume equation, and they told me that the volume was 36 pi. So instead of v equals 4/3 pi r cubed, I put 36 pi, right? I plugged it in right here, 36 pi. Okay, I canceled out the pi's. I multiplied by 3/4 on both sides, reduced. Cubed root of 27 is 3. So now I know that my radius is 3. When the volume is 36 pi. So I put that in my dr dt over here. Okay? So that information helps me plug in for the rest of the problems. Okay? So I plug in a 3 for R. I know that my dV/dt is 7. They told me that in the very beginning. So I just multiply out 7 over 36 pi centimeters per second. I know it's centimeters per second because radius is a distance, right? So I just put right there, the radius is changing at a rate of 7 over 36 pi centimeters per second. All right, so there's that one. Any questions on this one before I move on? So hopefully that wasn't too bad. I know a lot of people were telling me like they were having problems with it because they didn't know what to do with the volume, but eventually I told them like, hey, just think about it this way. The volume is just trying to tell you like you could solve for your radius by using this volume in the equation. So once they were told that, they were okay. Okay, question number 3. It says a kite 100 feet above the ground is blown away from a person holding its string in a direction parallel to the ground at a rate of 10 feet per second. At what rate must the string be let out when the length of the string already let out is 100 feet? 200 feet. So let's draw a picture here. It says a kite is 100 feet above the ground. Okay, so 100 feet above the ground. So it's 100 feet, and your kite's up here. We'll just put the actual kite there. So there's your kite, okay? Now it's tied up to a string. So we're going to call that S. So a kite 100 feet above the ground is being blown away from the person holding the string. So there's a person here holding the string, and it's being blown away from that person in a direction parallel to the ground. Okay, so this kite is moving this way. Okay, parallel to the ground. Well, the ground for me would be considered like X, right? I would think of this would be X. So that means that this kite is being blown away parallel to the ground at a rate of 10 feet per second. So dx dt, okay, because that's the direction it's moving, the same as X would be, is 10 feet per second. At what rate must the string be let out? So the string is S, so ds dt. Okay, at what rate must the string be let out when the length of the string already let out is 200 feet? So when S equals 200. So again, what shape are we dealing with? Triangle. Based on the information I gave you, what formula should I use? Pythagorean's theorem, right? This is a 90. So we're going to use x squared plus 100 squared equals s squared. Now, I just broke one of the rules I told you guys, right? Don't ever plug in numbers into an equation. Unless what? Unless it's constant. Do they say anything about this thing moving up or down or anything like that? Thank you. Is this who for? Is this for the teachers? Okay. So yeah, if it's a constant, right? So they say it has to be a constant. They don't mention anything about the kite going up or down or anything like that, right? So it is going to be a constant. Okay. Now my next step is to find ds dt. So let's take a derivative of this. So a derivative of x squared is 2x dx dt plus the derivative of 100 squared. Well, I don't really care what 100 squared is. All I know is it's going to be a constant, right? It's going to be a number. So what's the derivative of a number? 0. And then s squared becomes 2s ds dt. Okay? Notice I can divide everything by 2 to cancel it out. So I'm going to cancel it out here. So this is what I end up with. X dx dt is equal to s ds dt. Now, I need ds dt, so let me divide by s. I'm going to rewrite this. Ds dt is equal to x divided by s dx dt. Now, they said, what's the rate of change of the string when the amount of string let out is already 200? So that means S is 200. dx dt is 10. What's x? Well, here we go. If this is 100 and this is 200, then what's x? Right, so this should be just a Pythagorean theorem problem. So x squared plus 100 squared is equal to 200 squared. So x squared is equal to 200 squared. What is that? 4 and 1, 2, 3, 4 minus 1, 2, 3, 4. So x squared is 30,000. So x has to be plus or minus the square root of 30,000. Now, that would be plus or minus 100. Oops, I'm sorry, I forgot to put equals. Plus or minus 100 radical 3. Am I right on that? I think I am, because it's 100 times 100 times 3. So each 100 has a 10 rad, so that's 10 times 10, so that's 100 radical 3. So that's our x value. It's 100 radical 3. We use the positive because remember, distance can't be negative, right? So there you go. Now we start canceling some stuff out. So this 0 will cancel with that one. This 0 will cancel with that one. This 2 will make this a 5. So we have 5 radical 3. And what are my units? This is the length of a string over time. Feet per second. Now, of course, they're going to want you to write a sentence for this, okay? Every time you're doing AP stuff, they want you guys to write something about it. So when they ask, at what rate must a string be let out when the string of the length, when the string's already at 200, the string should be let out at 5 radical 3 feet per second.
This will be sent through Piazza, right?
Yeah, and right now I'm trying to screencast it, so I might actually be able to send it out as video. So let's see. I don't know how big the file is going to be. I don't know if it's going to take it 6 hours to upload. I have no idea. So we're about to find out. So I'm hoping it'll work easy. Or maybe I can like lower the quality to make it smaller and stuff, but we'll see. Yeah. Any questions on this one? How many of you guys got this one done? So a couple. Did you guys get this answer?
No.
Okay.
I know where I messed up.
All right. All right. So, I mean, I know these are hard, so don't feel like, oh my gosh, I can't get this. But you got to keep working at these things because they are difficult, but they are very common questions. Okay, these are the types of questions that you will see on any AP exam. So you got to make sure that you understand how to do them. Now, the next problem is another flying a kite problem, right? But this one has you do something different. It says a kite is flying at an angle of elevation of pi over 3. So I'm going to kind of just draw that. So here's our kite again. I don't know why we draw bows on them, but I've always drawn bows. I have no idea. Maybe it's a I'm so old type of thing. But all right, so this is a pi over 3 angle of elevation. It says the kite string is being taken in. So that means that the rate of change for that kite would be negative, right? Because it's being taken in. So a kite string is being taken in at a rate of 1 foot per second. So ds dt is equal to -1 feet per second. It says if the angle of elevation does not change, so hey, that means it's constant, okay? I can use it. How fast is the kite losing altitude? So that means my y value, okay? They want to know dy dt if theta is pi over 3. Okay, they said if the angle of elevation does not change, how fast is the kite losing altitude? Notice I don't need to include my x value here. I know we're dealing with the triangle, but I'm also dealing with angles. And they talked about the string, the hypotenuse. They talked about the height, my y. And I know trig functions that deal with opposite and hypotenuse, right? We know sine. So I'm going to do sine theta is equal to y over s. Okay? Now, before you take your derivative, you got to think this through. You could take your derivative of both sides and you'd be okay. You're just going to have to do a quotient rule on the right side. Or you can recall that they said that sine of my angle is constant. So sine of pi over 3, sine of 60 degrees, that's radical 3 over 2. If I have to get s by itself, or eventually I got to get s by itself, right? Why don't I separate it from that fraction? Let me shoot that over to the other side. So s radical 3 over 2s is equal to y. Now, since my goal is to get ds dt, then maybe I should get that rad 3 over 2 and throw it to the other side as well. So at least it's going to be an s by itself. So s is equal to 2 over radical 3 y. And now when I take my derivative, I'm going to have ds dt immediately. So ds dt is equal to 2 over rad 3. Remember, it's a product of a number times a function, so that number gets ignored. You just do the derivative of the function. But y is, actually, you know what? I'm solving not for s, I'm solving for y, aren't I? Right? Sorry, dy dt. Oh, I did the wrong thing. I should have not solved for s. Let's erase that part. I thought we were solving for s, but it's supposed to be for y. So it's actually good the way it is right now. So let's take our derivative of both sides, okay? So the derivative of the left side would be radical 3 over 2 ds dt equals to dy dt. Now they said figure out dy dt when theta equals to rad 3 over 2. Well, I already plugged that in because it's not changing, right? So I just got to plug in my ds dt. So let me put dy dt when theta equals to pi over 3 equals to radical 3 over 2 times -1. So that's equal to negative radical 3 over 2. Now that's the rate of change of the height over time. And height was given to me in I said 1 foot per second, so in feet per second. Does it make sense that my answer is negative? Yeah, because you're losing height. You're not gaining it. Okay? So we just want to write down a sentence for the question. How fast is the kite losing altitude? Well, the kite is losing altitude at a rate of radical 3/2 feet per second. Notice I didn't put negative, okay? Because if you say that a kite is losing altitude at a rate of negative radical 3/2, then you're saying it's losing at a negative. So a minus and a minus, you're really saying it's gaining. Okay? So the negative is implied when you're saying losing. You could say the kite's altitude is changing at a rate of negative radical 3/2. So that means you didn't mention anything about direction. So then let the negative do that for you. You could do that too. Questions on this one? So draw a picture. It was key that we were able to figure out that the angle was constant. And then from there we were able to solve for that. We'll try doing one more here. Let's see. Number 5. And we'll try leaving 4 for tomorrow. Maybe we'll do up to 6. But number 5 says sand is dumped off a conveyor belt into a pile at the rate of 2 cubic feet per minute. The sand pile is shaped like a cone whose height and base diameter are always equal. So that's kind of important. Height and base are equal. At what rate is the height of the pile growing when the pile is 5 feet high? The volume of the cone is V equals to pi over 3 r squared h, where h is the radius and base. H is the height and r is the radius of the base. So let's see. To start off, sand is dumped off a conveyor belt. So there's some kind of conveyor belt. And there's going to be some sand on top of that conveyor belt. And that sand is dumping itself off on the ground. And it's creating a cone. Now, sand is dumped off a conveyor belt into a pile at a rate of 2 cubic feet per minute. Cubic feet per minute. What is that? Rate of, and then they say cubic feet per minute. What are my values? Like, what am I taking a derivative of? dv dt, right? dv dt. Cubic feet, that's a volume. Per minute, that's time, right? So volume over time. So the sand is dumped off a conveyor belt into a pile at a rate. So that means this pile is getting bigger. So that's a positive. Cubic feet per minute. Okay, the sand pile is shaped like a cone whose height and base diameter are always the same. So this height, let's call this h. Excuse me. Give me a second. Excuse me. I'm allergic to fake flowers. So what's my radius? Half of the height, right? So half height. Because they said that the diameter and the height are the same. So if I draw the radius, that means that my radius is half the height. Notice instead of an r value, I've instantly eliminated my radius and changed it into an h value. Okay, is that a good thing to do? I don't know. Maybe the best thing would have been for me to write the radius on the bottom and then put the height as twice the radius. I don't know. We're about to find out, okay? So let's see. Sandwich pile, the cone height and the base diameter are equal. It says, at what rate is the height of the pile growing? So they want dh dt. So it's good that I have h's there. dh dt. At what rate is the height of the pile growing when the pile is 5 feet high? When h equals 5 feet. Okay, so that's what we're looking for. So remember, they gave us this equation, right? Of v equals to 1/3. Do they do 1/3 or pi over 3? Pi over 3, sorry. So pi over 3 r squared h. But we know that the radius is h over 2 squared. Right? Half the height. So the volume is pi over 3 h squared over 4 times h. So volume is equal to pi over 12 h cubed. So there's my volume. Okay, now they want the rate of change of the height, so I'm going to have to take a derivative, okay, on both sides. So let's go ahead and do that. dv dt is pi over 12 times 3h squared dh dt. Now that 3 and the 12 will reduce. That'll be a 4. This will be a 1. So we have dv dt equal to pi over 4 h squared dh dt. Now remember, I'm trying to solve for dh dt. Okay, so I'm going to divide everything by pi over 4 h squared. So dh plus u dt is equal to dv dt divided by pi over 4 h squared. Now, they said find the rate of change of the height when the height is 5. So, let's do that. So, finding dh dt when h equals 5 is equal to, now dv dt they told me was 2 cubic feet per minute. So that's 2 over pi over 4 times h, which is 5 squared. So that's equal to, that would be 8. So 8 over 25 pi, because the denominator of 4 is going to shoot up. So that goes up to the top. So that's an 8 over 25 pi. My units here for height, they said feet high, so it would be feet per minute. Does it make sense that the height is positive? Yeah, because it's growing, right? So we just got to write a statement here. At what rate is the height of the pile growing when the pile is 5 feet high? So you could say when the pile is 5 feet high, the height, whoops, let me spell that right. The height of the pile is growing at a rate of 8 over 25 pi feet per minute. A lot of the AP exam has to do with explain. Can you explain this? Can you explain that? Okay, so that's one of the things that we kind of have to be aware of. Like, make sure that you understand the work that you're doing. Not just can you do it, but can you translate it? There's a lot of times when they say, like, write an equation for the average rate of change of the following information. Then they'll tell you, what does it mean? What are you actually finding? So you have to make sure you can tell them, like, oh, it's the rate of change of the temperature over this interval with this much time, or something like that. You guys have to be able to give them an explanation, because they're checking, like, do you understand what you're doing, or are you just a robot that can do work, right? So they want to make sure you're understanding what you're doing. Questions on this one? Again, drawing is important. The setups, the equations, understanding your goal, okay, knowing what you're trying to solve for, okay, not just taking derivatives of random things, but knowing, like, okay, why did I substitute for r immediately, right? Well, because I have 3 variables in one equation, so I better get rid of one. Which one should I get rid of, right? If they wanted to find the rate of change of the radius, I would have to get rid of h, in which case you would want to do this. That's what you would have wanted to do for the substitution if they wanted a rate of change of radius, right? You want to keep your radius, so you want to change your height to a 2r, because they said the radius is half the height, so that means if the radius is r, that means the height must be twice as big, right? So you got to be aware of what's given, what you need, so you can change things however you want. All right, we'll do 6. I think we still have time for that, or no? We got on 10 minutes, so let's try 6. All right, so let's see. All right, so it says a camera is located 50 feet from a straight road along which a car is traveling at 100 feet per second. The camera turns so that it is pointed at the car at all times. In radians per second, how fast is the camera turning as the car passes closest to the camera? So we have a situation kind of like this. So here's your camera. Here's your little car. All right, now the car's moving this way. Okay, so, and it's getting closer and closer to this point right here, because that would be the closest distance, right, for the car to the camera, right, when it's directly above it. Because right now that it's diagonal to it, that hypotenuse is longer than my opposite side to that car, right? So they'll be at the closest whenever that car is directly above it. Okay? So let me reread this here. It says, a camera is located 50 feet from a straight road along which a car is traveling. So this distance here is 50 feet. Now that camera is not moving in terms of distance to that point, okay? It is moving by revolving, but not to that point over here, okay, this point right here. So 50 feet from a straight road along which a car is traveling at 100 feet per second. Well, normally we would call that x, right? That's my direction for x. So that means that dx dt, the car, is moving at 100 feet per second. Now it says the camera turns so that it's pointed at the car at all times. In radians per second, so now they kind of tell me, look, there's some angle here, okay, that's changing over time. In radians per second, how fast is the camera turning as the car passes closest to the camera? Okay, so what can I use for this problem? I know I have a triangle. Say again?
Tangent.
Yeah, tangent, right? I can use tangent. By the way, the main question said, find the rate of change of the angle, right? when it's closest. Okay, so there's no real way for me to kind of write that out. I can say when S is equal to 50, but we may not even need an S value here. Okay, so let's see. So we're going to use tangent of theta equal to x over 50. Okay, and the 50 can stay because that's a constant. Okay, I don't have to put y or anything like that. That's never changing, so I can plug it in. Let's take a derivative of both sides. So the derivative of tangent of theta is secant squared theta d theta dt. So that's my objective there. My derivative of x over 50, that's 1/50th times x, right? So it's basically a 1/50th dx dt. Okay, so that's going to be my value here. Now I need to find d theta dt. So d theta dt is equal to, I'm going to divide both sides by secant squared. So 1/50 secant squared theta dx dt. Now I'm going to kind of change that secant squared theta into cosine squared theta over 50 dx dt. So we have dx dt. I can plug it in right now. Then we got to figure out what we do after. So we put cosine squared theta over 50 times 100. We're going to be able to cancel one of these things. And then the 5 will go away. That'll become a 20. I'm sorry, not a 20. It's just a 2. So we have 2 cosine squared theta. So what should I do from here? Cosine, it's giving me 2 cosine squared theta. I'm going to kind of go up here. What do you guys think? When it's closest to, right? So when it's closest to cosine of theta, is cosine of theta not 50 over s? Right? Isn't cosine of theta equal to 50 over s? You guys agree? Well, when the car is closest, what is s? Huh? 50. So that's going to give me a 1. What's theta when cosine of theta equals to 1? A 0, right? Cosine theta equals 0 when the car is closest. Makes sense, right? Shouldn't that angle be completely closed? Right? All right, so far makes sense. So if that's the case, then let me plug that in. So d theta dt, when theta equals 0 radians, right, 0, is 2 times cosine squared of 0, right, which is basically 2 times cosine of 0 squared, while cosine of 0 is 1. So this would be 2. Now, the measurement of angles are in radians, so 2 rad per, and this was given to me in feet. In time, feet, 100 feet per second, so radians per second. So this one's a little different because they didn't actually give you a measurement on the triangle. They actually gave you the measurement of the angle, but they don't really make it obvious, but it is there because when they say when this car is at its closest point, so you have to understand the closest point is when that angle is completely straight up, right? When that angle is closed off. So that's 0 degree or 0 radians. So just write your sentence. Says, how fast is the camera turning as the car passes closest to the camera? Say the camera is turning at 2 radians per second when the car is closest to the camera.